This is Radio TV Phono Nut, and we have a small box that was sent in by a friend, and it contains an RCA transistor radio that he would like repaired. Apparently it was in some sort of an accident. I think they had it in a car and somebody pulled out in front of them and they had to slam on brakes and the radio went flying and it never worked again after that. So we're going to try to make it work again. He said it was a nice performing radio and that he would like to keep it if possible. So let's open this up and see what we've got with this dull box blade. Alright, here we go, and this sure looks like it's packed better than some of the eBay stuff that I get. Look, double boxed. And my friend doesn't play around. When he boxes up a radio to send to me, he wants to make sure it gets there in one piece. These eBay sellers that I deal with, they couldn't give a rat's behind. Just take your money and throw it in a box and whatever happens will happen. If it gets broke, we'll just blame it on the post office and won't accept any responsibility ourselves. That seems to be the way of society this day and time. Let's just blame somebody else, you know. Let's not take any responsibility ourselves. Alright, where's my dull box blade? Alright, here we go. Yep. Nice little radio. Alright, here we are with the back cover removed. This set operates off of 4 pin light batteries, and I believe he said the problem was no audio, and I think he said he connected a ammeter to it and it was drawing way too much current. So we'll have to find out what's going on there. Alright, let's get it apart and see what we've got to work with. Here we are taking apart. Looks like an 8 transistor chassis. I can see that some of the electrolytic capacitors have been replaced in the not too distant past. Yeah, he said this was a very sensitive radio, that he could pick up stations on it that he couldn't get on other radios, so that's the reason he'd like to have it fixed, and we're going to try to accommodate him there. Okay, we're back. I have the 6-volt power supply connected to the radio with our amp meter connected in the hot line so we can measure the current draw, so I can tell if there's too much current draw or too little current draw. Set to 200 milliamperes. Let's turn it on and see what we're drawing. We're drawing about 56 milliamperes. I'm getting a little audio action whenever I... Okay, that's off. I want to go the other way. Kind of hard to do this one-handed. It's always nice to have 2 digital multimeters. As cheap as this one is, it still does what we want it to do. I have one connected monitoring the current draw, and I have this other one to check voltages, and I want to check the B+ input into the driver transformer. Alright, we have, get on there, 5.6 volts. And on either side we have 5.6 volts. That goes over to your output transistors. And when I touch the input of the transformer, I get a very faint buzz in the speaker, which tells me the the audio output stage is at least working somewhat. Now let's work our way back to the volume control in the driver stage and see what kind of action we get there. Alright, I'm touching the center of the volume control and getting even less of a hum there than I'm getting here at the driver transformer input, so that tells me there's a problem here in this driver stage. I shouldn't be getting less of a hum here, I should be getting more of a hum. Alright, I'm looking at what I think is the driver transistor. The boards are kind of difficult to find components on sometimes since they don't road map the underside of the board, and I'm getting basically nothing there, no voltage there to speak of, and no voltage here to speak of, so we need to look at this area here. Okay, here's a schematic diagram that I obtained from the internet. Things always go better when you have a schematic diagram to work on something with. And basically what's happening, the output of the detector diode goes down to the volume control. Output of the volume control goes into this AF amp transistor. And the output of that transistor goes into our driver transistor. And it's kind of odd here where RCA chose to place the earphone jack. Most radios have that on the speaker output, but in this case they have it at the output of the driver transistor. And of course when you plug in an earphone, it disconnects the signal which would normally go out to your driver transformer, and then of course the output of the driver transformer would go to these two audio output transistors. And this is why you always read the fine print on the schematic. If you look at the collector of this AF amp transistor, they want 6 volts on the collector, and as you can see the collector connects to circuit ground, and just looking at that, like, wait a minute, how could there be 6 volts on something that's connected to circuit ground? Well, if you'll read this fine print down here, they want you to reference your voltometer, or in our case, our digital voltmeter, to the plus side of the battery terminal. They don't want you to use circuit ground for the reference there. So yeah, when we do that, our voltages on these driver transistors, actually our voltage on all of these transistors are just way out of the ballpark. The only thing that's even close to being right is our output stages here, but everything else is way off. We have 6.5 volts on the collector and about the same voltage on the emitter and base of both transistors, so we need to look into that. Alright, this is turning into an interesting project, to say the least. The only voltages that check remotely right are the ones that's on the two audio output transistors. And according to what the owner told me, the radio was working fine. It was on the seat of their vehicle, and they ended up having to slam on brakes because of some idiot driver, and the radio flew off the seat and hit the floor, and it failed to work after that. And that leads me to believe that we probably have a hairline crack in the circuit board somewhere. So what I'm doing now is I'm going through and checking the continuity of everything, every path with my ohm meter. I've already checked the path that goes from you'll see it goes from one side of the off-on switch through a 100 ohm resistor, and then through a 270 ohm resistor up to the emitter of this driver transistor. And I just simply checked from the emitter to the other end, to the end of the off-on switch, and I'm reading around 370 ohms, so that tells me that path is good. And that's really about the only thing I know to do at this point. Okay, this resistor here, 82K, it connects from the base of the AF amp transistor to ground. It reads about 100K. I didn't really think that would have any effect on the operating condition, but I went ahead and replaced it anyway, and as I suspected, it didn't have any effect on our operating condition. And at this point, I'm really at a loss as to what could be wrong with this. Every transistor in here, for the exception of the audio output transistors, have too much voltage on all terminals. It's like the transistors are not even conducting. I can't find anything broken, although I'm sure I'm missing something somewhere. But I've learned whenever you get frustrated and things are not going right, the best thing to do is walk away from it for a few hours or a few days or whatever, and then get back on it. And I think that's what I'm going to do now. I'm going to call it a day on this, and whenever I regroup, I'll get back on it and hopefully find out what's wrong with it, and probably feel like an idiot whenever I find out what's wrong with it. So, with that said, we're turning the lights off, and that's going to do it for right now. Okay, it looks like this capacitor is in backwards according to the schematic. This side here connects back to this end of this 100 ohm resistor, and the other end of the 100 ohm resistor goes back to the power switch and then back to the plus side of the battery. So we're going to remove this capacitor, check it and make sure it's still okay, and then flip it around. Alright, I did a continuity check here. You see we have a 100 ohm resistor coming off of one side of the power switch, and if you also notice, it also splits off up here to the final audio output stage. Well, I said earlier that was the only part of the radio that's even remotely working correctly, and then it comes off here and goes through this 100 ohm resistor to the other areas of the radio. Well, I did a continuity check, checking all of the traces where it branches off into these various areas, and I can't find anything wrong. I flipped around this electrolytic capacitor that was in backwards, and of course that didn't make any difference. And there's so little voltage across it right now, it wouldn't have mattered no way, and I think I found out part of the reason why there's little voltage across it. I tested with my ohm meter from the end of this 100 ohm resistor where my screwdriver is pointing, between that and actual circuit ground, and I'm reading about 2 ohms. So that tells me that something is shorted here somewhere. Something is not right. Now what we have to do is go down through the B+ line and find any components with a direct path to ground, as in no high value resistors between the B+ line and, say, a transistor. I'm looking at this electrolytic cap right here. Look at here. See that electrolytic cap right there? One end of it connects between the end of that resistor and ground, and I might mention that that capacitor has been replaced. Now, I don't know if it's bad yet or not, but it's a prime suspect. Well, it's not the electrolytic capacitor, and I know some people are probably saying those never short anyway. Well, yes, they do. I've had these little low-voltage electrolytic capacitors short at least twice during my years of working on electronics. One was in a Newcomb record player that you've seen a video on, and the other one was in a 25-inch Zenith TV from the 80s that was fixed long before I even knew YouTube existed. So, yes, they can short, but unfortunately in this case, it's not the problem. I've done some more looking, and the only other obvious place I can see is where it enters into this final IF transformer. There's no correct path to ground, but I guess there could be a short in the IF transformer that would create a path to ground. So let's check that now. I want to check from pin 5 on this IF transformer to ground, and I should not get anything at all. Alright, here's pin 5, of course, with it still in the circuit, and we're reading a low resistance there. Now let's unsolder pin 5 and see if the short goes away. If the short goes away, then we know the trouble's in this IF can. Okay, pin 5 is disconnected, and looky there, no short. Well, at least we can say one thing about this video. We might have gone in circles a little bit, but at least this wasn't a standard capacitor replacement job, and I kind of like these non-standard, non-capacitor replacement jobs because it just proves what me and Shango and some more people have said, that it's not always about the capacitors. There's a number of other things that can cause problems. And this falls into one of those other things. Now, I applied power with the shorted transformer out of the circuit, and as you can tell, our audio circuit has come to life now. So yeah, I think once we repair or replace that transformer, we should be back in business, I hope. Now, if we look at the transformer, what's actually grounded is pin 6 on the primary winding, and of course the outside metal shield can. And pin 6 is this little guy right here, and of course this is the tab for the outside metal can of the transformer. Alright, let's get it out of the board and see if we can find out exactly what's going on here. Okay, I've unsoldered the other pin, and that goes to ground. And I've determined that the short inside of the IF transformer actually exists between these two pins. In other words, it's not some kind of short between this pin and the outside can of the transformer. It is something inside of the transformer that's shorted. Alright, transformer's out of the circuit. Is the short still there? It indeed is. So as I proved earlier, there's no short to the case. It's actually inside the transformer. So let's pull it apart and see if we can determine if it can be fixed, or am I going to have to find another transformer. If I need another transformer, I've got a similar RCA radio of my own. It's my personal radio that kind of works. I may just go ahead and take a transformer out of it, and then I'll worry about finding a transformer for mine later. Okay, I've looked this over and I really don't see any way I can repair this. It appears to be a primary to secondary winding short. Most likely, somehow or another, the insulation on one of the windings, or both of the windings actually, got nicked and created a short between the primary and secondary. This here, that's our capacitor that's across the primary winding. I don't see any problems there. So about all I know to do with this is try to find another IF transformer, and maybe this thing will sing again. Okay, here's my radio. It's very similar to his. We're going to open it up and see if it has the same IF transformer. If it does, we're going to borrow it, and then I'll worry about finding one for mine later. Okay, we have the IF transformer swapped out. Let's turn it on and see what happens. I bet it'll pick up a station. Well, if I can get to the tuning condenser, well, hang on. Well, there we go. Here we are, almost back together, running off of the DC power supply, and the radio is passing the sensitivity test. We're picking up 670, which is our low-powered urban gospel station from across the state line. Well, not low-powered by FCC definition, but it's not no 50,000-watt flamethrower either. But yeah, this used to be a decent music station until the guy who owned it passed away, and his son took it over and turned it into this kind of station. So about the only use this station is to me now is to check the performance of radios.
Minuscule. And finally people looked into it and they found out that he was paying himself an income every year of like $60,000. And therefore paying income.
The vistas, and it's dramatic. So it makes
Here's one of our music stations. Some of the older stuff they play I can deal with, but I don't care for the more modern R&B that they sometimes play. Here's our Southern Gospel station.
Then you put, if they don't play, they put.
And that's a sports station. So now you know pretty much what we have on AM. At least we have some music, but I'd like to have a dedicated 50s, 60s, and 70s oldies station, which probably will never happen.
They do. Put it on the top. So the steppers game we played then is the same game.
Alright, just for fun, we're checking the current draw on the properly operating radio, and we're drawing about 12 milliamperes. That seems to be a lot better than the 50-something that we were drawing when the radio was not working properly. And that really should have tipped me off more than it did at the time, but what did I tell you earlier in the video? Let me regroup and I can figure this out. Well, I regrouped and I figured it out, obviously. And as you can see, the current draw is fluctuating with the music, or should I say the chatter. And when I turn it all the way up...
You're listening to the Laura Ingraham Show. Road rage is worse now than it was 20 years ago.
You can see we draw a good bit more current, and that's perfectly normal for these types of radios. And what you'll get out of that is, obviously, your batteries will last longer if you play the radio at as low a volume setting as possible. Don't just blast the thing because you can. But yeah, this is one for the books. Final IF transformer was shorted primary to secondary, and that was just killing the B+ voltage to the other stages of the radio. And we replaced a couple of resistors that was out of tolerance, and we turned an electrolytic capacitor around that was in backwards, and it seems to be working okay now. Alright, there you go. Hope you got something out of all this, and more to come later.
And, you know, in Japan, remember
Crazy how people make up lies and tell a story so false.
See, I can remember when all these stations had music on them. There wasn't no talk, blabbermouth crap around here. It was all music.
Plant, when they had the...
4109, Highway 39 North, here in Meridian. Sunday school is at 10. Morning worship at 11. Sunday evening worship at 6. And Wednesday night Bible study at 7. For more details...
Come on.
98. That's 601-595.
One day I need to get my little Part 15 station set up, and then I can have my own private oldie station to listen to over all these old radios that I have around here. And what's really bad is there was a lot of AM radios made back in the day that were really nice performers. Push-pull audio output stages, RF amplifiers, wide bandwidth reception, but there's not much on AM worth listening to, you know, and if you find a station that has something on it that you like, the technical quality is usually not the best in the world, so you're really defeating your purpose when you have as good a radio it was ever made, but if the incoming signal is crap, it's not going to help much.
Specifications. Act now before steel prices go up.
All right, there you go. More to come later.
800-9